Beneath the infinite canvas of the night, a solitary radio dish tilts skyward, its metallic frame trembling against the hush of the cosmos. Silence stretches beyond comprehension, a darkness so complete it seems almost sentient, indifferent to the dreams of the small creatures beneath it. Yet, for decades, humanity has sent its ears into that vast quiet, listening, hoping, straining against the void for a single, unmistakable voice. In that stillness, every faint whisper of radio waves becomes a prayer, a fragile thread of order piercing the eternal static, an echo of meaning in a universe that seems otherwise unbound by comprehension. It was in 1977, amid this patient vigil, that the universe betrayed a flicker of mystery, a fleeting signal, catalogued simply as the wow. Signal, brief and singular, lasting only 72 seconds, yet igniting imaginations across the world. For one moment, it seemed as though the cosmos had spoken directly, a luminous thread of intention briefly cutting through the night. Scientists pored over the data, hearts measured by both skepticism and wonder, and yet the source remained unclaimed, a cipher in the dark. Was it a distant civilization, a passing comet, or some phenomenon yet undiscovered? The silence returned almost immediately, leaving only questions, and a lingering sensation that perhaps we were unprepared for the truth. The paradox is profound. We search for signals, yet our assumptions shape what we expect to find. We imagine language, intent, even morality encoded in frequencies, projecting humanity's understanding onto the universe's immensity. But what if these signals do not follow our patterns? What if they are more alien, more abstract, or simply beyond comprehension? What if the cosmos communicates in forms we cannot yet perceive, whispering in ways we cannot yet translate? In that moment, amid the spinning stars and the cold, immeasurable void, one cannot help but feel both insignificant and infinite. Humanity reaches outward, listening with every instrument, every pulse of ingenuity, for voices we may never fully understand. And yet, it is precisely in that striving, in the act of listening, that we confront a deeper mystery. We searched for contact among the stars, but perhaps we were never prepared for the language they might speak. Long before the first, enigmatic signals teased the ears of humanity. There was only curiosity, and the faint hum of a universe speaking in frequencies invisible to the eye. In the early 1930s, Karl Jansky, a young engineer at Bell Labs, was tasked with investigating the static that plagued transatlantic radio communications. Amid the crackle and interference, he discovered a subtle, rhythmic hiss originating not from the Earth, but from the heart of the Milky Way itself. For the first time, human instruments were listening to the cosmos on its own terms, attuned to whispers that had traveled thousands of years across the void. Soon after, Grote Reber, driven by fascination and a solitary resolve, constructed the first parabolic radio telescope in his backyard, mapping these cosmic signals with meticulous care. Together, their work unveiled a new universe, one of invisible light, of waves that carried the hidden story of stars, gas, clouds, and cosmic motion. As the world emerged from the shadow of the Second World War, the Cold War propelled technological ingenuity at a fevered pace, and with it, the dream of reaching beyond our world. Among these ambitions, the search for extraterrestrial intelligence, or SETI, began to take shape, an audacious endeavor that sought to answer a question older than civilization itself. Are we alone? In 1961, Frank Drake formalized this hope with a methodical calculation, later known as the Drake equation, estimating the likelihood of detectable civilizations in our galaxy. Yet in its precision lay poetry, each variable, a delicate gesture of both mathematics and longing, a measure of probability that also measured humanity's yearning. The 1960s carried with them the optimism of the space age. Rockets breached the sky, satellites orbited the Earth, and radio telescopes tuned themselves to the stars with unprecedented sensitivity. The possibility that a signal from another intelligence might already be traveling across the cosmos became tangible, a beacon awaiting recognition. Debate followed immediately. Some scientists dismissed the search as naively quixotic, a distraction from the rigor of terrestrial science. Others insisted it was the most profound inquiry any species could undertake, a question worthy of humanity's highest attention. In 1974, this aspiration became manifest in the Arecibo message, a carefully encoded transmission sent to the globular star cluster M13. Within it lay humanity's first attempt to speak deliberately to the stars, a visual representation of our biology, our numeracy, our home in the solar system. It was both a greeting and a declaration, cast boldly into a silent void that had waited eons to be heard. And yet, even as the message departed from Earth, the universe remained patient, indifferent, and infinitely mysterious, holding its secrets just beyond the reach of our instruments and imagination. The discoveries of Jansky and Reber laid the foundation for a new way of perceiving the universe, one that revealed the cosmos as a symphony of invisible frequencies, each wave a note in a composition too vast for human comprehension. Radio waves, traveling unimpeded through the darkness, carried the signatures of distant stars, supernova, and the swirling clouds of interstellar gas, allowing scientists to peer into regions hidden from optical telescopes. These early breakthroughs were not merely technical, they were philosophical. Humanity began to sense that the universe was not a silent void, but a place alive with patterns, rhythms, and the potential for communication in forms we had barely begun to understand. Every antenna trained skyward became an instrument not only of observation, but of contemplation, turning engineering into a vessel for existential inquiry. With the Cold War fueling both fear and innovation, space exploration became entwined with the pursuit of knowledge about life beyond our planet. The launch of satellites and probes opened our eyes to the immensity of the solar system, revealing moons with frozen oceans, planets with violent storms, and atmospheric chemistry hinting at processes that might sustain life. CTI emerged not as a fantastical notion, but as a scientifically grounded effort to detect patterns within the cosmic static, seeking traces of intelligence encoded in the language of physics. The Drake equation crystallized this ambition, translating the vast unknown into a framework of probabilities. Each factor's stellar formation rates the emergence of habitable planets. The lifespan of civilizations was a careful negotiation between observation and speculation, a bridge between rigorous science and the human desire to understand our place among the stars. The optimism of the 1960s space age was contagious. Humanity, propelled by the vision of reaching the moon and glimpsing the planets, began to imagine the possibility of contact with civilizations far older, far wiser than our own. Scientific discussions were intertwined with wonder. What would it mean if a signal reached us, unambiguously artificial and carrying intent? These debates, sometimes quiet and technical, other times passionate and philosophical, shaped the earliest attempts to communicate. The Arecibo message, with its precise encoding of numbers, chemical structures, and the solar system's architecture, was a gesture of audacious hope, a bridge cast across like reaching for understanding in a universe indifferent to our existence. It embodied both humanity's technical ingenuity and its profound vulnerability. The realization that to speak to the cosmos was also to confront the possibility that it might respond in ways we could not yet comprehend, even as instruments grew more sophisticated, capturing the faintest whispers from the stars. The universe remained enigmatic, a reminder that discovery is never complete, and knowledge is always provisional. Every breakthrough hinted at deeper mysteries, the vastness of the galaxy, the unknown lifespans of civilizations, the subtle interference of cosmic phenomena that could mask a message or mimic intelligence. In these quiet tensions, the interplay of hope and uncertainty, mathematics and imagination, observation and speculation, humanity began to understand that searching for signals was not merely an empirical pursuit, but a reflection of our own consciousness. The cosmos had become both a mirror and a mystery, and in the delicate act of listening, we were learning to hear not just the universe, but the yearning within ourselves. In the summer of 1977, the stillness of the cosmos was pierced by a single, ephemeral anomaly. For 72 seconds, a spike of intensity appeared on the screens of the Big Ear radio telescope in Ohio, narrowband signal so distinct it seemed almost deliberate, as if the universe had, for a fleeting moment, chosen to speak directly. The signal was catalogued simply as the WOW signal, its name drawn from the excitement scrawled in the margin of the data printout by the astronomer who first noticed it. In that brief window, the routine of scientific observation was transformed into a moment of electric wonder, a fracture in the steady silence of the sky that hinted at something far beyond human expectation. Astronomers approached it with a mixture of awe and caution. The excitement was tempered by rigorous skepticism, a reminder that the cosmos is both generous and deceptive. Natural phenomena often masquerade as signs of intelligence. Pulsars with their precise rhythms, distant quasars radiating with immense energy, satellites passing unnoticed across the sky. Could this signal be another astrophysical curiosity? A passing comet reflecting radio waves, or an artifact of terrestrial interference? Every possibility was weighed meticulously, every hypothesis tested against the unforgiving rigor of observation. Yet even as caution prevailed, the imagination stirred. What if it was not noise at all, but the echo of an intelligence elsewhere, reaching across light years, in a language we had barely begun to conceive? The broader world felt the impact differently. Media outlets transformed the anomaly into headlines of alien contact, projecting narratives of discovery and wonder, while the scientific community whispered uncertainty behind closed doors. The contrast was striking. Public fascination thrived on hope and speculation, while those trained in measurement and probability grappled with ambiguity, parsing the data for patterns that could never be fully confirmed. Beneath the calculations and statistical analysis, however, lay a quieter, more profound response, a deep hunger for meaning, an acknowledgement that even in the cold precision of numbers, humans long to detect a spark of recognition, a signal that might affirm we are not alone. Yet the WOW signal remained elusive. Follow-up observations returned only silence, leaving behind a trace, a question mark etched across decades of inquiry. Its fleeting presence illuminated the tension at the heart of the search for extraterrestrial intelligence, the struggle between hope and restraint, between the desire to believe and the discipline to know. In the aftermath, astronomers and dreamers alike confronted the realization that the universe may speak in languages we do not yet comprehend. offering glimpses that tantalize without revealing, whispers that inspire without answering, and mysteries that remind humanity of both its minuteness and its audacious longing to listen. In the weeks and months following the WOW signal, observatories around the world trained their instruments toward the same patch of sky, hoping to catch even a whisper of what had briefly appeared. Yet the universe remained silent, as if the anomaly had been a single, intentional gesture, a fleeting punctuation in the vast text of the cosmos. Each null result deepened both fascination and frustration. Scientists pored over old data, recalibrating instruments, re-examining archival recordings, and considering every conceivable source. Satellites, terrestrial interference, atmospheric phenomena, even errors in data handling, all were examined and eliminated as the signal continued to resist explanation. The process was painstaking, a dance of precision and patience, where every lead had to be interrogated and every doubt accounted for. In this meticulous labor, the line between discovery and obsession blurred, revealing the quiet devotion required to listen to the universe at its most elusive. Debate flourished within the scientific community. Some argued that the signal could be explained by rare natural processes, phenomena we had yet to fully understand, or even previously undetected astrophysical objects. Others allowed themselves the cautious thrill of possibility, considering for a moment that it could be the first tangible evidence of an intelligence reaching across the void. These discussions were often private, conducted in journals and observatory offices, where colleagues weighed probabilities against hope, seeking the balance between imaginative speculation and the stringent demands of evidence. The WOW signal, in its brevity, became a mirror for the human mind, reflecting our deep desire to find order, meaning, and companionship in a cosmos that is otherwise indifferent to such longings. The tension between public fascination and scientific caution became increasingly pronounced. Newspapers and magazines heralded the event as a potential first contact, painting stories of alien civilizations and cosmic messages, while researchers insisted on restraint, aware that a premature conclusion could undermine credibility. This duality, the imagination inspired by the unknown and the rigorous skepticism demanded by science, created a charged atmosphere where every observation carried emotional weight as well as intellectual significance. For those scanning the heavens, each signal, each blip of anomalous data was more than a technical event. It was a whisper of possibility, a suggestion that the universe might be capable of interaction, and that humanity might someday understand a dialogue written in the language of light and radio waves. Amid these cautious deliberations, an underlying truth emerged. The universe does not yield its secrets easily. The WOW signal exemplified this reality, a moment of astonishing clarity, followed by an enduring silence that forced reflection. It illuminated the delicate interplay between knowledge and wonder, between data and the human need for narrative. In the shadow of uncertainty, scientists felt both humility and audacity, recognizing that to listen was to confront the limits of perception and imagination. And within this space, between expectation and reality, between measurement and mystery, the search for extraterrestrial intelligence revealed itself not simply as a scientific endeavor, but as a meditation on humanity's place in a cosmos that is vast, enigmatic, and, perhaps, capable of speaking in forms we are only beginning to dream of. In the years that followed the WOW signal, astronomers returned again and again to the same patch of sky, their instruments reaching deeper into the void, searching for a repetition that never came. Each rescan, meticulous and deliberate, returned only silence, a stark reminder of the universe's indifference to human expectation. The absence of signal weighed heavily, yet it did not diminish the determination of those who listened. Every null result became a lesson in patience, an acknowledgement that understanding the cosmos demands both time and persistence. In these quiet campaigns, the act of searching itself became a meditation, a testament to the human willingness to confront uncertainty without abandoning hope. Technological advancement offered new possibilities. The construction of larger, more sensitive radio telescopes transformed the pursuit of extraterrestrial signals from a hopeful experiment into a rigorous scientific endeavor. The Arecibo Observatory, with its vast 305-meter dish, became a pinnacle of detection capability, able to collect signals from across the galaxy with unprecedented clarity. Green Bank and other facilities added to the network, each instrument tuned to distinguish the subtle contours of cosmic noise. With these telescopes came the need for precision, as every signal had to be carefully classified. Natural phenomena, human-made interference, and the faint echoes of distant stars were painstakingly distinguished, creating a taxonomy of radio waves that allowed scientists to separate the mundane from the extraordinary. Each anomaly was scrutinized and measured against the growing understanding of the cosmos, slowly refining the framework for what a genuine signal from intelligence might resemble. The growing sophistication of observation also revealed the universe's capacity to deceive. The discovery of pulsars in 1967, rapidly spinning neutron stars, emitting precisely timed bursts of radiation, demonstrated that seemingly intentional beacons could arise naturally, mimicking patterns that might otherwise be interpreted as artificial. These celestial lighthouses, their beams sweeping across space with relentless precision, reminded astronomers that the cosmos has its own rhythms, independent of human design. Decades later, the identification of fast radio bursts added a new layer of complexity. These millisecond-long flashes of energy, originating from distant galaxies, appeared without warning or repetition, defying easy explanation and challenging the boundaries of known astrophysics. Each new discovery blurred the line between the natural and the potentially artificial, forcing humanity to question what forms communication might take, and whether our instruments were even capable of perceiving them. Yet, despite years of scanning without a definitive answer, the human impulse to listen never waned. Generations of astronomers committed countless nights to the quiet vigil of observation, refining equipment, developing algorithms, and expanding the reach of their gaze. Each search was a negotiation with the void, a willingness to confront silence while remaining attuned to the possibility of revelation. In this relentless pursuit, a deeper truth emerged. The search for extraterrestrial signals is as much a reflection of human curiosity and persistence as it is an inquiry into the cosmos itself. It is a testament to the patient audacity of a species willing to extend its senses into the dark, to translate the universe's whispers into understanding, and to embrace the uncertainty that comes with exploring a mystery as profound and enduring as the silence from the stars. As technology advanced, the capacity to detect the faintest cosmic murmurs grew exponentially, transforming the early search for extraterrestrial signals into a precise and methodical endeavor. Observatories not only scanned the heavens, but began to catalogue and analyze every anomaly with meticulous care. Data pipelines were constructed to separate mundane noise static from distant lightning storms, reflections from satellites, or terrestrial interference from phenomena that might carry patterns suggestive of intelligence. Each burst, each irregular blip, was examined against the expanding map of known cosmic activity. And yet, more often than not, the signals dissolved into silence or revealed themselves as natural phenomena. The process demanded an extraordinary patience, as nights of observation yielded only fragments, each compelling in its potential but inconclusive in reality. Yet, through this painstaking work, astronomers honed their ability to listen, to discern structure within chaos, and to distinguish the universe's deliberate rhythm from the coincidental. The universe, it seemed, had a habit of teasing its observers. Pulsars, with their steady, lighthouse-like emissions, were initially considered as possible candidates for artificial signals, their regularity hinting at intelligence. Only through careful measurement did it become apparent that these were neutron stars, collapsed remnants of massive suns, rotating hundreds of times per second and emitting beams of radiation as a natural consequence of their physics. Even as these discoveries clarified some mysteries, they introduced new challenges, forcing scientists to reconcile their desire for contact with the knowledge that the cosmos possesses its own extraordinary behaviors independent of life. Similarly, the eventual discovery of fast radio bursts, decades later brief, powerful flashes of energy emanating from galaxies millions or even billions of light years away, revealed that the universe itself is capable of producing signals that defy expectation. These phenomena complicated the early frameworks for expanding the parameters of what signal might mean and compelling scientists to think beyond familiar patterns of communication. Amid these technical and theoretical advancements, the human dimension remained central. Astronomers, engineers, and technicians devoted years to scanning regions of the sky where anomalies had appeared, returning to them again and again despite the absence of repetition. Each observation, each refinement of instruments, became part of a quiet narrative of persistence, a testament to humanity's willingness to pursue the unknown without certainty of reward. The absence of repeated signals was not discouragement, but a challenge, a reminder that understanding the cosmos requires both humility and perseverance. In this continuum of effort, the act of listening itself became a meditation, an acknowledgement of the vastness of space, the subtlety of signals, and the patience necessary to interpret what the universe allows us to perceive. Through these early investigations, the foundations were laid for a search that would continue for decades. A search defined as much by human resilience and imagination as by scientific technique, ever attentive to the possibility that the cosmos might one day speak in a way that resonates with the deepest curiosities of the mind. In the decades following the wow signal, the universe continued to whisper in fleeting fragments, offering tantalizing hints of complexity that defied easy explanation. Among these, the discovery of repeating fast radio bursts marked a turning point. Signals that returned from distant galaxies not as singular events, but as recurring flashes of energy. Unlike the brief anomalies of the past, these bursts suggested structure, a rhythm that hinted at intentionality, or at least at processes so precise and ordered that they seemed to mimic communication. For astronomers, each repetition was both exhilarating and disorienting, challenging existing models of astrophysics and forcing a reconsideration of what might constitute a signal in the vast, dark ocean of space. Technological leaps amplified this capacity to listen. Instruments such as the Canadian Hydrogen Intensity Mapping Experiment, CHIM, transformed radio astronomy with sensitivity and scope previously unimaginable. Vast arrays of antennas now scanned the sky in continuous vigilance, capturing thousands of bursts each year. providing data streams that rivaled the human imagination in complexity. Alongside these instruments, global collaborations emerged, uniting the efforts of SETI, Breakthrough Listen, and distributed networks of amateur and professional observers. Every corner of the planet became part of a collective ear, attuned to whispers that traveled millions or billions of light years. The human species acting as a single conscious listener, suspended in the vast silence of the cosmos. Yet the signals themselves remained enigmatic. Narrowband emissions appeared intermittently, sometimes precise, sometimes chaotic, often disappearing before they could be thoroughly examined. Each detection sparked hope, speculation, and a growing awareness that the universe communicates in ways beyond human comprehension. Patterns emerged, only to dissolve under scrutiny, suggesting that what might appear deliberate could instead be natural. Phenomena operating under conditions we have yet to imagine. Pulsars, magnetars, and cosmic plasma all conspired to generate energy in forms that both mimic and confound the search for intelligence. And the line between the artificial and the astrophysical became increasingly blurred. Through it all, a haunting realization took shape. Every signal, every anomaly, every brief flash captured in the night sky raises more questions than it answers. The universe seems to speak in a language we are only beginning to hear, an intricate code woven from the interplay of matter, energy, and the laws of physics. Each observation is a meditation on scale, a reminder of our smallness, yet also of our audacity to reach out and interpret these distant messages. In the search for patterns and intention, humanity confronts its own limitations and its deepest aspirations, standing at the edge of understanding, aware that the cosmos may be more articulate than we are, yet capable of grasping, and that even in silence it continues to provoke wonder and reflection, inviting the mind to listen, imagine, and persist as observations accumulated. Patterns emerged that both fascinated and perplexed astronomers. Some repeating fast radio bursts arrived in clusters, their timing and intensity varying in ways that hinted at complex underlying processes. These bursts, originating from galaxies billions of light years away, carried energies surpassing what our sun emits in days, compressed into mere milliseconds. The sheer magnitude of these signals challenged imagination, raising questions not only about their origin, but about the physical mechanisms capable of producing them. Were they natural phenomena, highly magnetized neutron stars, or magnetars, undergoing sudden structural shifts? Or could they be technological in origin, the work of an intelligence using methods and motives beyond human conception? Each hypothesis expanded the horizon of possibility, and yet the true source remained elusive, a ghostly imprint in the fabric of space-time. Meanwhile, advances in data processing transformed the nature of discovery. Artificial intelligence algorithms and machine learning began to parse mountains of radio data, identifying subtle anomalies that human eyes might overlook. Networks of telescopes now operated in concert, coordinated across continents, sharing real-time observations to track bursts and refine their localization. The combination of technological sophistication and international collaboration created an unprecedented sensitivity to the faintest cosmic voices. Even as these systems increased the likelihood of detection, they also revealed the depth of the challenge. Signals were often ambiguous, fleeting, and complex, resisting simple classification. In this relentless pursuit, the act of listening became both a scientific exercise and a meditation on patience. a way of attuning humanity to rhythms that extend far beyond the scale of everyday experience. The psychological and philosophical dimensions of these breakthroughs were profound. Every new detection brought exhilaration tempered by uncertainty, a reminder that the universe may be far more intricate and inscrutable than previously imagined. These bursts, fleeting yet powerful, suggested a cosmos alive with processes that could be interpreted as a form of communication, or as the echoes of forces that operate on scales and in manners that defy human intuition. In contemplating these signals, astronomers faced not only the limitations of their instruments, but the limits of their imagination, grappling with the tension between expectation and reality. In this tension lay the essence of the mystery. The universe speaks in ways we are only beginning to recognize, offering glimpses that inspire both wonder and humility. Ultimately, the breakthroughs of this period reinforced a haunting truth. Understanding the cosmos is not merely about decoding signals, but about expanding perception. Each FRB, each narrowband anomaly, each fleeting trace of energy is a lesson in scale, in patience, and in the audacity of curiosity. They remind humanity that the universe does not yield its secrets easily, and that the act of listening, even in the absence of certainty, is itself a profound engagement with the infinite. In the accumulation of data and the careful pursuit of patterns, a philosophical awareness emerges. The universe may be communicating in a form that transcends expectation, inviting not immediate answers, but reflection, wonder, and the persistent courage to listen, knowing that the next signal, if it comes, could reshape our understanding of life, intelligence, and the nature of cosmic connection. As the search for extraterrestrial signals continued, a profound realization took hold. The universe may not communicate in ways that align with human expectation. The assumption that alien civilizations would transmit messages resembling our own structured, linguistic, intentional reflects the limitations of anthropocentric thinking. Intelligence elsewhere, shaped by environments and physics alien to Earth, may produce signals incomprehensible to human senses. Forms of communication encoded in wavelengths, energies, or temporal patterns beyond current detection. Each fleeting anomaly, each burst of energy that defies classification, becomes a reminder that humanity's instruments are calibrated not only to the wrong scale, but to the wrong imagination. The universe may be speaking in a language that demands not translation, but transformation of perception. Some scientists have proposed the cosmic zoo hypothesis, a tantalizing yet disquieting framework. Perhaps civilizations exist, yet deliberately conceal their presence, aware of the dangers inherent in contact with unknown species. Signals, if they exist, could be masked, filtered, or encoded in ways that purposefully evade detection, leaving observers to confront only shadows of the true activity. This notion reframes silence not as absence, but as intentional, deliberate quiet that challenges human presumption. In such a cosmos, what is interpreted as emptiness may be a mirror, reflecting humanity's own impatience and desire for confirmation. The universe, in its vastness, resists simplification, offering glimpses that tease the mind but evade definitive understanding. The problem of scale compounds this uncertainty. Signals traversing the galaxy are subject to distortion. The vast distances stretch wavelengths. Cosmic plasma scatters radio waves, and the relentless expansion of space itself dilutes information across billions of light-years. What begins as a coherent emission may arrive at Earth fragmented, ambiguous, or buried in the overwhelming noise of countless celestial sources. Even with our most sensitive instruments, the faintest whispers may remain indistinguishable from natural phenomena, leaving human observers to wrestle with patterns that may be illusionary, accidental, or beyond current comprehension. In such conditions, every detection carries a dual significance. It is at once a potential revelation and a testament to the fragility of human interpretation. This tension intensifies the paradox of silence. Echoing the question famously posed by Enrico Fermi, "Where is everybody?" The absence of obvious contact confronts humanity with its own expectations, forcing reflection on the rarity of life, the longevity of civilizations, or the possibility that intelligence is inherently transient. Yet even as the cosmos remains ostensibly quiet, subtle anomalies repeating FRB's narrowband bursts, fleeting signatures insist upon attention, hinting that what we call signals may not be messages at all, but phenomena beyond comprehension. They challenge the mind to consider that detection may be a function of perception rather than presence, that the universe may be abundant with activity entirely imperceptible to human frameworks. Within this landscape of uncertainty, the psychological burden is profound. Every data point becomes a mirror, reflecting not only the cosmos, but the expectations, desires, and biases of those who observe it. Scientists are forced to confront the uncomfortable possibility that hope and imagination shape interpretation as powerfully as empirical evidence. Each anomaly carries both the thrill of potential discovery and the weight of ambiguity, a reminder that the pursuit of understanding is as much a journey inward as outward, in the face of silence, distortion, and the unknowable. Humanity continues to listen, aware that the universe may be speaking constantly, yet in ways that require not only better instruments, but a deeper transformation of thought, perception, and imagination. As the complexity of the search became more apparent, it was clear that human perception is constrained not only by technology, but by the very frameworks through which we conceive communication. What we interpret as signals may be nothing more than transient alignments of cosmic phenomena, events that appear deliberate only because the mind seeks patterns. Magnetars erupting with sudden bursts of energy, pulsars rotating with perfect regularity, or distant quasars flickering in ways we cannot predict, could be misread as intent. Yet these same phenomena also hint at the extraordinary richness of the universe. Forces and events operating on scales and energies far beyond daily experience, suggesting a cosmos whose language is not ours to translate, but ours to witness in awe. The deeper the investigation, the more it becomes a dialogue with mystery itself. A conversation conducted in silence, punctuated by fleeting flashes of incomprehensible insight. This interplay between perception and reality fuels both hope and frustration. Some researchers consider that alien intelligence, if present, might communicate in modes entirely unrecognizable, modulations of gravitational waves, neutrino pulses, or quantum fluctuations that elude current detection. In such a paradigm, the very notion of listening requires a radical expansion of methodology, a willingness to confront phenomena that do not fit human preconceptions of signals. Every detection that seems anomalous may thus serve as both an invitation and a challenge, a reminder that discovery is contingent upon our ability to imagine, to extend our senses, and to embrace uncertainty. It is a meditation on epistemology itself, underscoring the fragility of certainty in the face of a cosmos that has had billions of years to evolve forms, processes, and interactions utterly alien to human cognition. Amid these reflections, the silence of the cosmos becomes paradoxically instructive. Absence, as much as presence, conveys meaning not as a definitive answer, but as a guide to the limits of perception. The Fermi paradox remains ever present, echoing in every null result and every fleeting anomaly. If life is common, why do the signals remain elusive? Perhaps the answer is that intelligence is rare, ephemeral, or inherently hidden. Or perhaps the signals are there, but the human species lacks the perceptual or conceptual tools to recognize them. In either case, every investigation transforms into an encounter with humility, a recognition that understanding may require patience spanning generations, instruments yet unimagined, and minds capable of perceiving beyond familiar frameworks. Each signal, each silence, thus becomes a lesson in perspective, forcing a confrontation with scale, time, and the limits of comprehension. Ultimately, the mystery deepens not because the universe refuses to communicate, but because its language may be fundamentally different from the one humans expect. What we call signals may be phenomena that challenge every assumption about intelligence, pattern, and purpose, leaving the observer suspended between hope and uncertainty. And in that suspension lies the philosophical resonance of the search. Humanity stands at the edge of understanding, listening not only for answers, but for the very possibility of a language that exceeds imagination. The cosmos, in its patient, indifferent vastness, continues to offer glimpses, hints, and provocations, reminding us that the act of listening is itself a profound engagement with existence, a meditation on the unknown, and a reflection of our enduring desire to connect with something far greater than ourselves. At the frontiers of observation, the universe begins to reveal its most exotic possibilities, where the familiar rules of physics twist into extremes that challenge both measurement and imagination. Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's, erupt with sudden bursts of energy capable of producing millisecond flashes detectable across the cosmos. Jets expelled from supermassive black holes traveling near light speed carve channels of radiation through interstellar space, bending and focusing energy in ways that can mimic structured signals. Plasma lensing, the bending and amplification of electromagnetic waves by clouds of ionized gas, further complicates perception, transforming ordinary emissions into seemingly deliberate pulses. Each phenomenon reminds observers that the universe possesses its own forms of complexity, capable of generating patterns that might appear artificial, yet arise entirely from natural extremes. In confronting these forces, humanity is forced to redefine what constitutes a signal and what remains the rhythm of the cosmos itself. Some theorists have begun to wonder if the very fabric of space-time might play a role in the signals we detect. Gravitational interactions, the warping of light, and the subtle ripples of gravitational waves could produce phenomena that appear structured or intentional. Artifacts not of intelligence, but of the dynamic geometry of the universe. A brief pulse might be an echo of matter orbiting a black hole, or the refracted energy of a neutron star flare across cosmic distances, distorted by expansion and scattering. To interpret these events as messages would be to project human expectation onto physics itself. Yet, within that projection lies fascination. The idea that the universe may itself be capable of generating patterns beyond human comprehension, inviting inquiry not just into life, but into the hidden potentials of reality, where information and energy intersect in forms yet unimagined. The concept of technosignatures opens an equally compelling and speculative frontier. Hypothetical megastructures such as Dyson spheres, artificial energy beams, or other planetary-scale engineering projects could produce detectable anomalies, subtle imprints of intelligence writ large across interstellar space. Unlike traditional messages, these manifestations may not be designed for human comprehension, but for practical purposes entirely alien to us, their detectability arising as a byproduct rather than intent. This convergence of astrophysics and astrobiology expands the search beyond signals alone, urging observers to seek fingerprints of civilization embedded in cosmic phenomena, whether in stellar luminosity variations, energy emissions, or the architecture of orbital systems. Each detection or non-detection offers insight into both the possibilities of life elsewhere and the limits of instruments calibrated to the familiar. Despite these advances, a haunting limitation persists. Humanity may be blind to signals that exist entirely outside the perceptual and technological frameworks currently available. Our radio telescopes, while astonishingly sensitive, are tuned to a narrow band of the electromagnetic spectrum. Our assumptions about patterns, repetition, and structure may bias the very searches we undertake. The universe could be teeming with activity, yet entirely imperceptible to observers constrained by current physics and instrumentation. The signals we detect may be only fragments of a far richer tapestry, hints that the cosmos is alive with processes we cannot yet interpret. In this extreme edge of science, the act of listening becomes an exercise in humility, a confrontation with the possibility that what we seek is present and persistent, yet exists in dimensions, energies, or forms beyond human perception. To stand here is to face the sublime, a universe that is vast, indifferent, and yet full of intricate complexity, offering glimpses of intelligence and structure that may forever challenge understanding, while compelling the mind to imagine, to expand, and to persist in the pursuit of what might lie just beyond the edge of knowing. Amid these exotic possibilities, the line between natural and artificial phenomena becomes increasingly tenuous. A burst of energy from a magnetar could be mistaken for intent, yet it is born purely from the violent interplay of matter and magnetism. A black hole jet sweeping across interstellar space might carry an intricate structure in its emissions, an unintentional pattern that resembles deliberate signaling. Even cosmic plasma, shifting and refracting waves in unpredictable ways, can create illusions of order in a sea of chaos. In confronting these extremes, astronomers are forced to reckon with the possibility that the universe itself possesses forms of communication beyond conventional definition, lexicon of energy, motion, and geometry that challenges the anthropocentric framework upon which so much of the search has been built. The notion that signals might exist in dimensions beyond human perception is equally compelling and disquieting. Perhaps life, or intelligence, interacts with space-time in ways that produce phenomena entirely invisible to current instruments, gravitational waves encoding bursts of information, neutrino streams carrying structure across light, or quantum-scale events whose patterns elude detection. These ideas push the boundaries of both science and philosophy, suggesting that the act of observation is inherently limited, that there may be activity around us that is persistent, structured, and meaningful, but forever imperceptible. To contemplate this is to confront the humility of human cognition, to recognize that the cosmos is not obliged to speak in the language we understand, and that the apparent silence of the universe may be an illusion, the product of perceptual and technological constraints rather than absence. Technosignatures expand this dialogue into realms of audacious speculation grounded in real physics. A Dyson sphere, encasing a star to harvest energy, would alter the luminosity curve of its host, producing a detectable anomaly across wavelengths. Directed energy beams, planetary-scale engineering projects, or large orbital structures might leave subtle traces in stellar observations, not as messages but as artifacts of activity. Searching for these signatures requires thinking beyond repetition or melody in a signal, toward the more abstract imprints of intelligence writ large across the cosmos. Each hypothesis challenges the very notion of detection. We are not only listening, we are interpreting the universe's architecture itself, searching for deviation from natural patterns that might betray the presence of the deliberate, the intentional, or the conscious. Ultimately, standing at this extreme edge of science is a confrontation with limits both of instruments and imagination. Even with arrays capable of scanning vast swathes of the sky in real time, and algorithms able to sift through immense datasets for anomalies, the universe may still harbor signals imperceptible to current technology. It is a realm where the line between seeing and missing, between knowing and speculating, is razor-thin. Each observation carries dual significance, a glimpse of extraordinary physics and a reflection on the fragility of perception. Here, at the threshold of comprehension, the search for extraterrestrial signals becomes not merely an empirical endeavor but a meditation on the nature of reality itself, a reminder that the universe may be infinitely articulate, yet eternally inscrutable. Speaking in forms our minds are only beginning to learn to imagine. As investigations into cosmic anomalies deepened, mainstream science turned first to the universe itself, seeking explanations grounded in known physics. Fast radio bursts, pulsars, and narrowband signals were examined under the lens of astrophysical rigor, each phenomenon a puzzle piece within a broader cosmic mosaic. Pulsars, with their clockwork regularity, revealed the extraordinary consequences of stellar death, collapsed neutron stars spinning with unthinkable speed, emitting beams of radiation that sweep across the galaxy like cosmic lighthouses. Fast radio bursts, initially baffling, have been traced in some cases to magnetars, hypermagnetized remnants capable of releasing bursts of energy equivalent to the sun's lifetime in mere milliseconds. These explanations situate the anomalies within natural law, grounding wonder in comprehension, and reminding humanity that the cosmos often surprises not with intent, but with extremes beyond ordinary imagination. The wow signal, however, resisted easy classification. Among the leading hypotheses was the cometary model, suggesting that hydrogen clouds from comets might have briefly produced the narrowband emission that Jerry Emmon famously recorded. Yet even as this explanation gained traction in some quarters, many scientists remained unconvinced. The signal's intensity, its precise alignment with the 1420 MHz hydrogen line, and its brevity posed challenges that ordinary cometary physics struggled to resolve. In the mainstream perspective, the anomaly was a call to caution, compelling, intriguing, yet insufficient to claim discovery of extraterrestrial intelligence. Here, the paradox of scientific rigor revealed itself. Extraordinary claims demand extraordinary evidence, and even the most tantalizing signal cannot bypass methodological discipline. Human interference further complicates interpretation. Satellites, radar systems, and terrestrial emissions all contribute to a background hum that can mask or mimic phenomena otherwise indistinguishable from cosmic signals. Observatories must constantly account for this contamination, differentiating between signals arriving from light years away and those bouncing off objects mere hundreds of kilometers overhead. Each potential detection undergoes scrutiny, algorithms filtering out predictable interference, cross-checks confirming authenticity, and repeated observations attempting replication. The mainstream SETI approach emphasizes patience, precision, and restraint, prioritizing the slow accrual of evidence over sensational interpretation. Signals are only extraordinary if they withstand rigorous testing, and the lessons of past anomalies underscore the necessity of skepticism alongside hope. This cautious methodology reflects a tension at the heart of the search, the paradox between human longing and scientific discipline. Every unusual blip on a radio telescope evokes curiosity, wonder, and the desire for confirmation that we are not alone. Yet rigorous science resists premature declaration. To assign intentionality to a signal is to risk projection, to mistake natural processes or even human artifacts for evidence of intelligence. Mainstream theory thus frames anomalies as invitations to understand, not proclamations of contact. Within this space between desire and doubt lies the subtle poetry of scientific pursuit, listening to the cosmos with instruments tuned to reality, aware of the heart's yearning but disciplined by evidence, following every possibility to its logical, carefully measured conclusion. In this deliberate patience, humanity confronts both the mysteries of the universe and the depths of its own longing, standing at the threshold of revelation while remaining mindful that true understanding demands time, scrutiny, and the courage to embrace uncertainty, even as mainstream science leans toward natural explanations. The persistence of anomalies serves as a subtle challenge, urging reflection on the limitations of current understanding. Some narrowband emissions resist classification, fleeting traces that emerge from vast datasets and vanish before replication is possible. Each anomaly prompts painstaking analysis, with astronomers cross-referencing stellar catalogs, plasma maps, and galactic surveys to rule out ordinary astrophysical causes. In doing so, they confront a tension inherent to empirical rigor. The universe may operate on scales, energies, and processes that exceed existing theoretical frameworks. What is dismissed as noise today may, with refined models or unforeseen discovery, become tomorrow's insight. This patient approach underscores the philosophical dimension of science. It is not merely the accumulation of data, but the cultivation of discernment, the ability to wait, observe, and interpret with humility. The rigorous methodology of SETI and astrophysics also highlights the human struggle between curiosity and certainty. The longing to hear a voice among the stars is ancient and profound, a reflection of our desire to connect beyond ourselves. Yet every potential signal must withstand a gauntlet of verification, replication, and critical scrutiny. Satellites in low Earth orbit, radar pulses, and terrestrial interference can masquerade as cosmic phenomena, producing illusions of design where none exists. Modern observatories, equipped with advanced filtering and machine learning, sift through torrents of data to separate artifacts from genuine anomalies, a process that can take months or even years for a single detection. The discipline required to distinguish between signal and noise transforms each observation into a meditation on patience, an acknowledgement that the cosmos does not yield its secrets to desire alone, but to careful, deliberate attention. Moreover, This approach cultivates a subtle philosophical awareness. The act of searching, even without definitive contact, is itself a profound engagement with the universe. By considering every possibility, natural, instrumental, or extraordinary, astronomers refine not only their understanding of astrophysics, but their sense of humanity's place in the cosmos. The wow signal, repeating FRBs, and other anomalies become catalysts for reflection, prompting the question of what it truly means to listen. Is detection sufficient? Or does understanding require a deeper alignment of perception and imagination with phenomena that may be fundamentally alien? In navigating this tension, mainstream science exemplifies a dual commitment: fidelity to evidence and openness to wonder. A balance that honors both the rigor of methodology and the philosophical weight of the mystery itself, even as evidence points overwhelmingly toward natural explanations. The enduring allure of what remains unexplained shapes the field. Each null result, each identification of human-made interference, is simultaneously a victory and a reminder of the vast unknown. It is a testament to human perseverance, the insistence on inquiry despite uncertainty, and the recognition that some questions may remain unresolved for generations. In this careful, measured pursuit, the search for extraterrestrial signals becomes not only a scientific endeavor, but a meditation on patience, humility, and the interplay between expectation and reality. It is here, at the intersection of rigorous method and imaginative possibility, that the true poetry of the search unfolds, listening to the cosmos with disciplined ears, yet allowing the mind to wonder, and to remain ever open to the extraordinary dot at the fringes of scientific imagination. Hypotheses emerge that stretch the boundaries of reason while remaining tethered to plausible physics. One of the most seductive is the notion of directed beacons, signals intentionally broadcast across interstellar distances, designed to announce presence to civilizations capable of receiving them. Unlike natural phenomena, these emissions would carry structure, repetition, perhaps even a simplicity tailored to bridge incomprehensible alien thought with human perception. The concept evokes a profound emotional resonance, a civilization reaching across the void, attempting communication despite the incomprehensible gulf of space, and in that imagined transmission, humanity glimpses both hope and humility. Yet the act of reception is fraught with ambiguity. The signals, if real, might be subtle, fleeting, or embedded within a torrent of cosmic noise, challenging observers to distinguish deliberate intent from the ceaseless turbulence of the universe. Equally compelling is the leakage theory, which proposes that signals need not be deliberate messages at all, but incidental byproducts of technology. Civilizations radiate energy through propulsion systems, planetary engineering, or communication networks, just as humanity inadvertently broadcasts television and radio across the solar system. From this perspective, every detected anomaly might be an echo of machinery rather than consciousness, a footprint rather than a greeting. Such a view reframes the search. The cosmos may teem with activity, yet its purpose remains indifferent to human desire for contact. In contemplating this, one recognizes the vastness not only of space, but of the subtle, unintentional impressions that intelligent life can leave upon the cosmos, patterns whose meaning is partial, accidental, or entirely obscured by our limited instruments. Some theories push even further, into realms where conventional physics itself becomes a lens of speculation. Could signals be encoded in quantum fluctuations, entanglement patterns, or subtle ripples in spacetime caused by massive gravitational interactions. Perhaps alien intelligence has transcended the biological, operating as post-biological entities that communicate through mechanisms beyond sensory perception, manipulating information in ways that defy classical understanding. In this domain, the universe itself becomes a medium, a substrate through which patterns, orders, and signals exist but remain largely imperceptible. To detect such transmissions would require not merely better instruments, but a conceptual leap, a willingness to entertain that the very fabric of reality could be shaped, guided, or harnessed in service of intelligence incomprehensible to the human mind. Speculation extends to the most radical extremes, where the universe itself may resemble a simulation. If reality is computational at its core, could so-called signals be glitches in the cosmic code, fragments of a higher-order program inadvertently leaking into perception? This notion reframes every anomaly as potentially epistemic, a reflection of limits in cognition or understanding rather than external intent. The unsettling possibility emerges that what is interpreted as communication repeating FRBs, narrowband pulses, or the wow signal itself might be indistinguishable from natural phenomena, perceived order arising from the mind's insistence on pattern. In this speculative terrain, the search for alien intelligence becomes inseparable from philosophical reflection. Every detection is a meditation on perception, interpretation, and the fragile boundary between what is real and what is imagined. It is a confrontation with the sublime, where the universe may be teeming with signals that our instruments and minds are yet ill-equipped to comprehend, and where the act of listening becomes as much an exploration of human consciousness as it is a pursuit of the cosmos. Even within the realm of speculation, the tantalizing evidence of anomalies compels rigorous exploration. Repeating fast radio bursts, for example, hint at a complexity that transcends simple natural mechanisms. Some bursts arrive with quasi-regular timing or frequency drift, provoking contemplation that they might encode information, or that they are shaped by processes far beyond conventional astrophysics. In this light, the universe becomes a vast stage where the boundary between intentional and incidental is blurred, where patterns might be signatures of civilizations operating on temporal and spatial scales that stretch human comprehension. To interpret such events is to confront the paradox of insight. Every clue inspires both exhilaration and caution, revealing the cosmos as simultaneously intelligible and maddeningly elusive. The notion of post-biological or non-human intelligence amplifies this tension. Civilizations might evolve beyond organic form, existing as networks of computation, consciousness embedded within matter and energy, interacting through mediums that humans have yet to perceive. In such a scenario, what is detected may not be language in any familiar sense, but energetic modulations, gravitational waveforms, or quantum fluctuations acting as a medium of thought. The universe itself becomes a canvas for cognition that transcends perception, a dimension of intelligence expressed not in speech or code, but in phenomena that human minds interpret only through approximation. Each ambiguous signal thus becomes a meditation on the limits of comprehension, a reminder that discovery may depend not only on improved technology, but on an expanded capacity to imagine forms of existence radically different from our own. Some of the most radical speculation extends to cosmological and metaphysical implications. Simulation theory, for instance, reframes every anomaly as a potential artifact of the underlying computational substrate of reality. Signals may not originate from other civilizations at all, but from structural imperfections, redundancies, or debugging remnants embedded in the cosmic framework. This concept transforms the act of observation into an encounter with the unknown architecture of reality itself. Every signal is simultaneously a potential message, a natural event, and a philosophical reflection on the nature of existence. Such perspectives are disorienting, yet they illuminate the profound depth of the search, where astrophysical rigor and imaginative inquiry intertwine, revealing that the quest for extraterrestrial signals is inseparable from the exploration of human consciousness and the structure of reality itself. Ultimately, the speculative domain underscores a humbling truth. The universe may be brimming with intelligence and activity, yet entirely inscrutable to our current senses. Signals may be everywhere, interwoven with natural phenomena, hidden within dimensions, frequencies, or processes that remain beyond perception. To listen is to embrace uncertainty, to acknowledge the potential that comprehension may require centuries, novel paradigms, or even a radical transformation of thought. In this space of ambiguity, the search is as much about expanding human imagination as it is about detection. Every burst of energy, every anomaly recorded by telescopes, becomes a meditation on possibility, a reflection on the fragile boundary between the known and the unknowable, and a call to persist in the pursuit of understanding a universe that may speak in a language far stranger and more wondrous than humanity has yet conceived. Across the modern landscape of cosmic inquiry, humanity has marshaled unprecedented resources in the quest to discern signals among the stars. Breakthrough Listen, one of the most ambitious projects ever undertaken in the search for extraterrestrial intelligence, exemplifies this endeavor. Vast arrays of telescopes sweep the skies night after night, recording signals across a broad swath of the electromagnetic spectrum, capturing subtle whispers that might otherwise escape notice. Every observation is a meditation on scale and patience. The data streams are immense, petabytes flowing like rivers of information, each byte potentially carrying a clue, a hint of intelligence, or the echo of phenomena yet unimagined. In this relentless scanning, the cosmos becomes simultaneously intimate and unfathomable, a space where human ingenuity meets the profound complexity of the universe. The role of artificial intelligence has transformed this search into a dialogue between human curiosity and machine perception. Algorithms comb through mountains of data, seeking patterns invisible to the naked eye, teasing out structure from the chaos of cosmic noise. Machine learning identifies subtle anomalies, filtering the mundane from the extraordinary, yet always under the watchful interpretation of scientists who must decide what qualifies as meaningful. In this interplay, the act of listening becomes a collaborative effort across minds, instruments, and computational intelligence, a choreography that mirrors the very phenomena it seeks to understand. Each candidate's signal, once flagged, is examined with meticulous care, evaluated against known astrophysical behaviors, human interference, and the subtle fingerprints of the instruments themselves. Global networks extend this vigilance, knitting together observatories across continents in a collective act of cosmic attention. The Allen Telescope Array in California scans vast swaths of sky with relentless efficiency. China's 500-meter aperture spherical telescope fast peers into the depths of the Milky Way with unprecedented sensitivity. Multi-messenger astronomy further expands the canvas. Optical telescopes, neutrino detectors, and gravitational wave observatories converge to paint a more holistic picture, ensuring that no anomalous event is examined in isolation. Signals are not merely sought, They are contextualized, mapped against the known rhythms of the universe, interpreted within the vast interplay of matter, energy, and space-time. In this meticulous effort, humanity stretches its senses across space and time, refining not just instruments, but the very frameworks of perception and understanding. The intersection with exoplanet science adds a profound layer of intimacy to the search. Telescopes now scan worlds with habitable zones, analyzing their atmospheres, rotations, and electromagnetic emissions for signs that intelligence might reside there. From the subtle flicker of a distant star to the shifting chemistry of a planet's atmosphere, the cosmos offers innumerable possibilities for detection, and the future promises even greater expansion. The square-kilometer array, once operational, will provide a sensitivity orders of magnitude beyond current capabilities, capable of revealing faint whispers that have thus far remained invisible. In these efforts, each observation is both a technical achievement and a philosophical meditation, a recognition that to listen across the universe is to confront both the vastness of space and the profundity of human curiosity, a pursuit that blends patience, imagination, and reverent attention to the mysteries that continue to elude definitive understanding, even as instruments grow more powerful and global collaboration tightens. The search remains fundamentally a human endeavor. Each signal that flickers, each anomaly that resists immediate explanation, rekindles a collective reflection on our place in the cosmos. The convergence of technology, computation, and imagination transforms listening into a multi-layered act of awareness, where the boundaries between science and contemplation blur. Here, at the cutting edge of observation, humanity stands vigilant, attentive not only to what is transmitted across light, but to the subtle lessons of patience, humility, and wonder that the universe insists upon. In the steady accumulation of data, the synthesis of multi-messenger signals, and the continuous refinement of instruments and algorithms, the cosmos gradually reveals the extraordinary complexity of its quiet language, challenging observers to attune their minds to possibilities far beyond immediate perception, and to remain ever hopeful that the next whisper from the stars might finally carry the unmistakable signature of intelligence. Each observation within these modern endeavors is not merely a measurement, but a meditation on patience and scale. The telescopes sweep the night sky with mechanical precision, yet the act of observation is inherently entwined with human anticipation. Scientists listen not only for anomalies, but for confirmations of their own hope that the universe may indeed contain minds parallel to our own. Even in the absence of definitive signals, every detection of repeating patterns, every calibrated measurement of cosmic radiation contributes to a slowly unfolding narrative of the cosmos. The data becomes a conversation across time and space, a dialogue in which the universe speaks in pulses, echoes, and subtle modulations, and humanity responds with curiosity, perseverance, and imagination. The integration of multi-messenger astronomy transforms these endeavors from isolated searches into a grand symphony of perception. Radio signals are cross-referenced with gravitational waves, neutrino bursts, and optical transients, revealing a universe more interconnected than any single instrument could perceive alone. In doing so, researchers can contextualize anomalies within a cosmic tapestry, distinguishing events shaped by natural physics from those that might hint at intelligence or structure. It is in this synthesis that the poetic dimension of modern science emerges. The cosmos is not a silent void, but an intricate, layered orchestra of energy, matter, and information. Each instrument, whether telescope, detector, or satellite, becomes a means of attuning human awareness to rhythms far beyond the terrestrial experience, bridging the intimate and the incomprehensible. The ongoing refinement of algorithms and AI introduces yet another dimension of perception. Machine learning can reveal patterns in petabytes of data that human analysis would miss, capturing subtle periodicities or unusual frequency modulations that hint at anomalies worth investigating. In this, technology becomes both a magnifying glass and an interpreter, extending not just human reach, but human imagination. Yet the machines do not replace the reflective human mind. Every anomaly flagged demands careful scrutiny, debate, and philosophical consideration. Scientists must decide what is meaningful, what is noise, and what might even represent phenomena entirely unknown to contemporary physics. This interplay between human discernment and artificial intelligence embodies a broader lesson. The act of listening is simultaneously empirical and contemplative, mechanical and poetic, looking toward the next generation of telescopes. Such as the square-kilometer array, the sense of potential becomes almost tangible. Sensitivity will increase exponentially, survey speeds will accelerate, and entire regions of the sky will be mapped in unprecedented detail. Yet these technological leaps carry with them a profound humility. Even with superior instruments, the universe may continue to conceal its messages in forms that challenge comprehension. Each new detection, each null result, reminds humanity that the search is as much about understanding itself, the patience to observe, the restraint to interpret carefully, and the courage to confront ambiguity, as it is about finding life beyond Earth. In the orchestration of these efforts, from the meticulous sweep of radio arrays to the subtle interpretation of multi-messenger signals, humanity stands as a witness, listening attentively to a cosmos whose language is still largely unknown, yet whose call continues to inspire wonder, reflection, and the enduring pursuit of understanding. Decades of listening have passed, each year stretching into the next, as telescopes sweep the heavens and computers sift through petabytes of cosmic murmurs. Yet the universe has remained quieter, at least quiet in ways we can recognize. The absence of clear messages carries its own weight, a profound paradox that reverberates through both scientific and human imagination. It is a silence that demands interpretation, one that is neither empty nor meaningless, but layered with possibility. Perhaps the universe speaks in forms that elude current instruments, or perhaps it has always spoken and we are merely unprepared to understand its syntax. In the quiet, the mind turns inward, contemplating not just the cosmos, but the very nature of perception, expectation, and longing. This silence is not merely absence. It is a mirror reflecting our own hopes, our fears, and the innate yearning to belong within the cosmic narrative. The emotional weight is immense, the loneliness of being a species suspended on a small planet, gazing at infinite skies, constructing instruments of extraordinary sensitivity, yet confronting the humility of insignificance. The contrast is stark. Our minds, capable of imagining contact across light years, yet grounded on a pale blue dot, uncertain whether we are unique or one among countless intelligences. Within this tension lies a poetic truth. The search for alien signals may ultimately be a search for understanding ourselves, our desires, and the fragile beauty of curiosity that drives us to stretch beyond immediate comprehension. Signals, if they exist, may be less about other civilizations than about the human spirit itself. Each fleeting anomaly, each narrowband pulse, becomes a testament to our hope, a reflection of our courage to look outward despite the enormity of uncertainty. In listening, we are building ears for the stars, instruments of perception that extend our consciousness into the void. Yet the act of listening is itself transformative. It reshapes the observer as much as it seeks to reveal the observed. To confront silence is to confront our limitations, and within this confrontation arises a form of philosophical clarity. Understanding may not arrive as clarity, but as the patient recognition of our place within an immense and intricate cosmos. Perhaps, in the end, the universe is not silent at all. Perhaps it vibrates with complexity, speaking in a language beyond the faculties of infant ears, in signals woven into gravitational waves, quantum fluctuations, or the subtle drift of interstellar matter. Humanity may be like infants, straining to hear a speech we cannot yet decode, poised on the threshold of comprehension. The instruments we build, the telescopes we train, and the algorithms we design are extensions of this longing. Efforts to attune ourselves to a cosmos that operates on scales, timescales, and modes of expression that are profoundly alien. And in this pursuit between hope and humility, between expectation and mystery, we find perhaps the most poetic lesson of all, that the search itself is both question and answer, an affirmation of curiosity, imagination, and the unyielding desire to listen, to learn, and to remain forever open to the profound unknown. Within this vast, unyielding silence lies a subtle, almost imperceptible beauty, a reminder that the cosmos is not measured solely by its messages, but by the depth of attention it demands from those who listen. Each scan of the heavens, each meticulously recorded anomaly, becomes an act of reverence, a recognition that even the faintest hint of structure or pattern carries significance beyond immediate comprehension. The pursuit itself, decades of patient observation, of analysis, of wondering what might lie beyond, is a testament to the human capacity for curiosity, for imagination, and for hope. In confronting the unknown, we are forced to confront ourselves, our assumptions, our expectations, and the fragile boundaries between knowledge and mystery. There is also a profound humility embedded in this endeavor. To listen for signals is to acknowledge that the universe operates on scales and through mechanisms that may never fully align with human intuition. Planets orbit stars we may never reach. Energies flare across distances incomprehensible, and time stretches across billions of years in ways that dwarf our lifespans. In this perspective, humanity is both infinitesimal and extraordinary. Infinitesimal in scale, yet extraordinary in our desire to perceive, to measure, and to connect. The cosmos, in its vast indifference, becomes a mirror of our own striving, revealing both the limitations and the extraordinary potential of consciousness, to seek meaning where there may be none, or where meaning is encoded in forms we have yet to decipher. Yet, even in the face of uncertainty, there is wonder. The silence of the stars may itself be a form of answer, a subtle communication that emphasizes patience, observation, and reflection over immediate comprehension. Perhaps the universe asks of us not that we receive messages in ways we expect, but that we cultivate the capacity to understand subtlety, to recognize patterns within complexity, and to embrace the unknown as a space for imagination. In this, every telescope, every algorithm, every carefully analyzed burst of energy becomes part of a larger meditation on human aspiration, the yearning to connect, the courage to confront silence, and the grace to accept that the cosmos may speak in languages we are only beginning to learn. Ultimately, listening to the universe is also listening to ourselves. The The search for extraterrestrial signals mirrors the internal exploration of what it means to be human, our curiosity, our longing, our persistent hope that we are part of a larger story. The wow signals, the repeating FRBs, and every anomalous blip become not just scientific puzzles, but metaphors for the human condition. Moments of wonder, fleeting glimpses of possibility, and reminders of both our vulnerability and our resilience. Perhaps the universe is not silent at all. Perhaps it is alive with subtle messages, patterns, and rhythms that our infant ears cannot yet perceive. And in the act of listening, in the patience, rigor, and reflection that define this pursuit, humanity inches closer to understanding not just of the cosmos, but of the profound nature of consciousness, curiosity, and the delicate poetry of existence itself. The silence that stretches across the cosmos is not merely an absence of signal. It is a profound presence, a weight that settles over the imagination with the subtle insistence of eternity. For decades, humanity has constructed instruments capable of listening to the faintest vibrations of space, yet the universe responds with whispers, with echoes that are fleeting, ambiguous, almost coy. Every burst of energy recorded, every narrowband pulse that seems out of place, becomes a catalyst for reflection, a mirror in which our own longing is refracted. In seeking messages from afar, we confront the paradox of comprehension. The cosmos may teem with structure, with complexity, with intelligence that is incomprehensible. Yet our senses and instruments remain bound by the limitations of terrestrial physics and cognition. This tension is at once humbling and exhilarating, for it is a reminder that knowledge is not simply a matter of acquisition, but of patient attunement, of opening oneself to possibilities beyond immediate grasp. Humanity's endeavor to listen is inseparable from the imagination, from the capacity to project meaning where none is guaranteed. The construction of arrays like Arecibo, FAST, and the Square Kilometre Array represents not just technological achievement, but an embodiment of hope. Each dish, each antenna, is a monument to the human aspiration to understand, to perceive patterns hidden in the chaos of the cosmos. In this way, the search for extraterrestrial intelligence is simultaneously scientific and deeply poetic. It is an exercise in extending consciousness beyond the familiar, in training perception to catch traces of signals that may not conform to our understanding of communication. The universe does not operate on human timescales. It moves in epochs and spans, in frequencies and energies that stretch far beyond the immediate. The very act of listening, therefore, is an ethical and philosophical commitment, an acknowledgement of the patience required to engage meaningfully with phenomena that may never yield simple answers. The psychological landscape of this search is equally vast. To peer into the universe with the expectation of contact is to confront a unique form of existential tension. There is awe, certainly, and anticipation, but also vulnerability, the recognition that the cosmos may be indifferent to our presence, that intelligent life may be rare or inscrutable, and that the patterns we detect may be as much projections of our cognitive architecture as reflections of external reality. The human mind is exquisitely tuned to detect order. It seeks patterns in noise, narrative in coincidence. This cognitive tendency shapes the interpretation of signals like the wow signal, repeating FRBs, and other anomalies. Even as scientists apply rigorous statistical methods, cross-check observations, and eliminate terrestrial interference, there is a persistent awareness that every detection is filtered through the lens of expectation, that the act of listening itself imposes a framework of meaning on phenomena that may be inherently unknowable. Yet within this ambiguity lies profound philosophical richness. The silence of the cosmos can be interpreted not as emptiness, but as an invitation, a call to cultivate awareness, reflection, and humility. To listen is to recognize the vastness of scales, energies, and distances that define reality. Light from distant stars takes millions or billions of years to arrive. Gravitational waves traverse the cosmos slowly, subtly bending space-time as they pass. Even quantum fluctuations ripple beneath perception, hinting at structures and processes beyond ordinary detection. In contemplating such phenomena, humanity is confronted with the paradox of significance and insignificance. We are infinitesimal within the cosmic arena, yet we possess the capacity to perceive, to measure, to interpret, and to wonder. The act of listening is thus simultaneously an acknowledgement of fragility and a celebration of consciousness, a recognition that awareness itself is an extraordinary achievement within an immense, indifferent universe. The notion of cosmic quiet also carries an emotional and aesthetic dimension. There is beauty in the subtle rhythms, in the regularity of pulsars, the unexpected bursts of FRBs, and the stochastic dance of interstellar plasma. Each anomaly, whether fully understood or not, is an opportunity to engage with the sublime, to perceive a universe that is not merely a backdrop for human drama, but a dynamic, living, and intricately structured reality. In this context, silence is active, not passive. It compels reflection, provokes imagination, and shapes the contours of human curiosity. To measure, to record, and to analyze becomes an act of reverence, a ritual in which the observer participates in a dialogue across time and space, one that may never resolve but nevertheless enriches understanding, perspective, and emotional resonance. Humanity's longing for connection manifests in the projection of potential narratives onto the cosmos. The possibility that alien intelligence exists, whether as biological beings, post-biological entities, or forms utterly alien to human perception, invites speculation not only about technology or communication, but about consciousness itself. How might minds shaped by different physical laws or evolutionary histories perceive reality? How might their modes of thought and expression diverge so radically that even the most sophisticated human instruments fail to detect them? These questions highlight the profound humility inherent in SETI and related scientific efforts. The universe may host intelligences whose presence is fundamentally undetectable because it operates through mechanisms entirely beyond current frameworks. In this light, the search is both scientific and philosophical, an exploration of limits as much as of possibility. The integration of multi-messenger astronomy further complicates and enriches this reflection. By correlating signals across radio, optical, neutrino, and gravitational observatories, humanity attains a more holistic, though still incomplete, sense of cosmic dynamics. Patterns that emerge across these modalities reveal interactions of immense energy and complexity: neutron stars colliding, black hole mergers, plasma jets spiraling at near light speed. While many of these events are natural, they underscore the challenge of distinguishing intentional communication from the proportionary variety of phenomena inherent to the universe. Each potential signal, therefore, must be interpreted in the context of immense physical processes that can mimic design, encode information unintentionally, or generate effects beyond immediate comprehension. The search for extraterrestrial intelligence becomes inseparable from a broader contemplation of cosmic order. Complexity, and the human aspiration to discern meaning within a vast, dynamic reality. As technological sophistication increases, so does the philosophical weight of discovery. The advent of AI-driven data analysis allows patterns to emerge from immense datasets, yet interpretation remains human. Machine learning can detect subtle anomalies, yet the decision to classify an event as significant, natural, or artificial lies with the observer. This interplay emphasizes the inseparability of empirical rigor and reflective judgment. To listen is to observe, and to observe is simultaneously to imagine, hypothesize, and confront the limits of understanding. In this sense, SETI is not merely a scientific endeavor, but a meditation on epistemology, the study of what can be known, and how knowing shapes both perception and expectation. The ethical and existential dimensions of this search are profound. Humanity stands on a small planet within a vast galaxy, gazing into the dark with instruments that extend perception across light years. Each potential signal carries implications not only for science but for self-understanding. Confirmation of alien intelligence would transform philosophical, religious, and cultural frameworks, while continued silence forces introspection about resilience, hope, and the value of inquiry itself. The act of listening, therefore, becomes a moral exercise in patience and attentiveness, a demonstration of the willingness to remain open to the unknown and to acknowledge the fragility and contingency of understanding, even in the absence of clear communication. The act of listening reshapes human consciousness by focusing attention on distant, subtle phenomena. Humans cultivate habits of observation, reflection, and imaginative projection. The mind is trained to perceive faint patterns, to tolerate ambiguity, and to appreciate scales and rhythms far beyond daily experience. This process itself is transformative. It aligns human perception with cosmic processes, fosters humility, and cultivates a deeper appreciation for the complexity, beauty, and mystery of existence. The cosmos, in this sense, serves as a teacher, guiding humanity toward an expanded sense of awareness, patience, and reverence for phenomena that operate beyond immediate comprehension.